we kind of learned about new words here. It's precipitation, condensation, and evaporation.
And precipitation?
Precipitation is the droplets and the steam.
Okay, and that can fall as rain, can't it?
And evaporation is when
It's when water stops becoming a liquid and becomes a gas, and it goes upwards.
it comes into gas.
Yeah. Good girl. And sometimes precipitation can be rain, but also you said, Jack, it can be
Snow. You'll be using the earth that God gave you to use.
Okay, so that's a way of showing reverence, isn't it? Because we're making meaning about God's creation. Very good.
Experiment's kind of working a little, but we kind of didn't see the part when it goes down and turns into steam and all of these stuff that the water cycle does.
Okay. So your experiment is teaching about the water cycle, is it?
Yep.
So what can you see in your bag? Let me have a look closer.
That is more gravity than in space. So if there was no gravity here and I dropped my glasses, they would actually float. And they would probably float up to the roof.
So you're learning about gravity as well, because gravity makes it go. Look, I'm going to make it rain, I'm going to make it precipitate, look.
And it tells us that God has been creating these really good things.
Yeah. And you know, when you act like scientists and you investigate and you find things out, you're showing reverence to God by looking at creation and finding it very, very interesting. Yeah, so that's one way of showing one of our school values. Maybe you could show me. Are your experiments still around? You can show me?
Yes.
Let's have a look. Wow. So can you tell me a little bit about, like this? What's this here?
It's steam.
Steam. Okay. So what is steam?
It's stuff like when water gets hot, it goes up into the air.
Okay. All right. So that's called evaporation. It goes up as steam, doesn't it?
Yeah.
But these droplets, it's condensed again. Okay. It's come back to water, so it becomes gas and goes up, and then it condenses, and then if that was the clouds up in the air, what would be going to happen next? Do you think?
It will come down, and it would pour down. It goes in the cycle again.
Goes around the cycle again. So you don't.
It's going round and never stops.
Cool. Wow. Thank you for sharing that. What do you?
So also the Enviro Schools group has put up bird feeders for the birds, so that because some species of birds are endangered.
Okay. What does a species mean?
It's like a whole bunch. It's like a certain type of bird.
Okay.
That all together and stuff.
So you can categorise them because they've got similarities. You see, that's making meaning in science, isn't it? You use the right words and you put things in categories. That's what scientists do to make meaning. Fantastic. Joey, tell us about what you've learned.
So people test things to work and not work.
Okay.
Using battery to charge something, or using your hair to get electricity.
Okay.
Like a big power station or something.
Oh yeah.
Like that from the water, and then the water goes through to the dams and then makes it all go spin up and makes it into electricity with all big machines and that.
Okay. There's some pretty clever stuff that happens in there. It's to do with magnets and
it's
movement.
basically just there. It's not like basically anything that you can you can sort of store it, but it's not like it's easy to store. Because it's basically just there.
Okay.
Electricity, you can't really make electricity. We're always gonna have electricity. Electricity never gonna go.
Yeah. You can't make energy, can you? But you can change forms of energy. So you can turn movement into electricity.
You can transform it.
You could transform it. That's a good science word. Very good. Somebody mentioned kinetic energy before.
Oh yeah.
What's that?
That is movement energy.
Oh.
So what that is like chemical energy. When you eat your food, it's giving you chemical energy. And so kinetic energy is like it's movement energy, so when you're running and stuff.
Okay, so that's another example of transforming energy, isn't it?
And like driving your car and stuff.
Yeah. Very good. So again, you are thinking like scientists, you're making meaning like scientists, you're using the words, you're investigating things, connecting with God's world. Well done.
The ingredients are cornstarch and water,
Yeah,
or corn flour,
yeah.
and I'm not really sure why it is, but I'm pretty sure it's to do with the water and the cornstarch.
There's going to be something about the molecules in the cornstarch,
Yeah.
the way they go together.
Because when you hit water from a really high, it feels solid.
Yeah,
So I'm pretty sure it's like with the water mixing with the cornstarch, because when we're making it, all the cornstarch got really hard.
yeah.
So it might be the cornstarch that is making it all gooey.
So what I reckon your mission is next is to find out why it works like this.
Yeah,
How are you going to find that out, do you think?
look it up
Where are you going to look it up?
on Google,
Okay, do you think Google will tell you the answer?
probably.
Okay, I'm going to check in with you in a couple of days and see if you found out the answer.
Yeah.
It's going to be to do with the molecules in it, I'm
Yeah.
sure of it. But I don't know the answer at this point. So it would be great to find out a bit more about that, wouldn't it? Okay, so what scientists do is they investigate things. They try and find out the truth about things. So when you've got something like this happening, it's interesting, isn't it? And it makes you question. But then the next step is to follow through those questions and find explanations, isn't it, Danielle?
Yeah.
Because that's what a scientist would do.
I just need to empty out.
Okay, so what I was asking you before is, what does it mean to think like a scientist? How does a scientist think?
Asking a lot of questions and figuring out what materials you need
Okay.
to do the experiments.
Okay, so how does an experiment help you?
So you can figure out what you need to do.
It can help you find out more about your question, can't it? And you said something about experiments, indeed. So
Yeah, an experiment helps you understand more about your question, and you can do other experiments about that question to find out more about what you already know.
okay, about that.
When we were doing the experiment, we had too many variables, so we had to narrow them down so it would be like the same, except for one variable.
Okay. So why do you only need one variable?
So it's true information about the thing, because if you have too many, then it's too different.
Okay, so that really is thinking like a scientist, and that's how you find scientific truth, isn't it? But do you know what, in science, there's never a truth at the end of it. You're only finding a theory. So you find out something and you go, right, that's my theory about what happens, and I can test it. I keep testing it. So scientists are always testing and investigating and looking. Okay.
So our experiment for that is having cups filled with the same amount of water and wrapping them in black and white paper, so we can see which one absorbs more heat when they were placed in the sun and left there for a while.
Okay. Did you make a prediction about which one you thought would absorb more?
Yeah.
What was your prediction?
My prediction was that the black one would get warmer than the white one, because black absorbs more light and white reflects light
Okay.
and heat.
All right. And what did your experiment tell you?
That I was right, and the black cup water did heat up more than the white cup water.
Okay. So something that you'd have to do very carefully as a scientist is measurement. How did you measure the heat?
I used a measuring cup.
Measuring cup. But how did you measure the heat in the cup?
I used a thermometer.
A thermometer. Okay. Good boy. So that's a way of measuring. Scientists have to be very accurate with that, don't they? Good boy.
Today, when we were learning about fracking, and that it's going to start happening out near the coast, and it's when people put high pressure water into cracks in the earth, which drives out oil and gas, and it could cause oil spills and tremors, which in my theory could cause a chain reaction which has more earthquakes. So you want to add something? Okay. You talk about the pinwheel.
There's just been a big demonstration in England about that because they're doing fracking in England now, and there's demonstrations. People are not very protests. They're not very happy about it.
2.5 million people are protesting against it.
Okay.
So.
We certainly don't want any more earthquakes, do we? No. Okay. So do you know what? A scientist also has to think about things, has to know things, has to investigate, but sometimes also has to take action. Because what you're talking about is actually people need to take action so that we don't do these things in wreck our environment. Okay. What are you going to tell us, Atlanta?
Pinwheels to demonstrate how hydropower works.
Okay. So how does that tell us how hydropower works?
Because the force of the water moves the spoons, but like in reality on the actual dams it moves big turbines and then that generates electricity.
Okay. Do you know how it generates electricity?
It goes through penstocks, then into a power generator.
Tell me.
Into a power generator, and then it goes into use after it goes through penstock and gets generated.
Okay.
Are you scared?
So what turns it into electricity?
The turbines get moved, and well, in the article it talks about penstocks, and I don't really know how that works with the electricity, but I think it's something to do with the power generator inside.
I'm going to give you a clue. It's to do with magnets, and when you move magnets across copper wires, this is the basic explanation. It moves the electrons in the wires. So electricity is the movement of electrons. So moving magnets and wires creates electricity in the wires, and that's how the movement of the dam, the hydroelectric station, gets converted into electricity. So that's something you could probably do some more experiments on in class. I think that's the next thing you're getting onto. It's all very interesting, isn't it? So a scientist, what would a scientist do in that situation? You've read an article about it, so you understand some of it. You've done some experimenting, so you understand some of it. What would a good scientist do next? We're all scientists because we're all put on earth to find out more about God's creation. Okay, so every time we investigate something or question something, we are being scientists. So given that you understand a bit about hydroelectric power and you've experimented a bit with it, what do you think a good scientist would do next?
See what is in the real world.
Experiment it bigger.
Okay.
I don't know.
Experiment more. Yeah.
More bigger.
At this point, you as a scientist would try to come up with a really good question. And
Why does it move?
You know why it moves. How does the movement make the electricity? That would be your next big question. And I'll give you a clue as to do with magnets. So that's a further step for investigation for you. And that's what scientists do. They question, they investigate, they measure, they find out, they form a conclusion, and then they do it again and find out more. Yeah? Cool, well done, scientists.
Been using like the language of like scientific language, and we've written down like how about wind breezes, and we did like a thing about wind, and now I think we're starting on like electricity.
Okay. So you've really been focusing on explanation.
Yes, explanation.
Okay, all right. Have you tied that in with your writing?
Yeah.
Yeah. Okay.
Yeah.
So what sort of writing would a scientist do? Like, would there be lots of similes and adjectives?
It's more like direct and like just straight on, just this like explanation writing where you go this and this and this and this and this.
Okay.
Instead of
So a sequence of
sequence.
in explanation.
Yeah.